Okay, welcome to video 4, section 3.5 in our calculus book. Want to talk about something called jerk. And jerk is defined as the rate of change of acceleration with respect to time. Now, this is actually what makes you motion sick. If you think about acceleration, if you sit in a car, it's a nice smooth road, you accelerate at a smooth, steady pace, don't generally actually get motion sick. But imagine that you're on a bumpy road and the person that you're with keeps doing this with the accelerator and you're shaking back and forth this way and you're shaking up and down this way. Then you start to get motion sickness. So it's these changes in acceleration that actually make you motion sick. So when we think about this, if we extend this, since we know that acceleration is derivative of velocity, that means that jerk must be the second derivative of velocity, and we can carry that on to the third derivative of position, or we could write this as the third derivative of position. We do need to be a little bit careful there that we don't think that that's cubed. Normally, if we wanted to cube a function, we would do this rather than put the cube. Except, of course, when we are writing sine cubed of x, which does in fact mean sine cubed, not the third derivative of sine. So if we could make it any more confusing, just let us know and we'll do our best here in the math world. Thankfully, I'm just a math teacher, not the guy who has to make these decisions. So, what do we know? A couple things. First of all, the acceleration due to gravity is equal to negative 32 feet per second per second. But of course, that means that the jerk due to gravity is zero. Derivative of a constant is zero. The slope of a constant flat line is zero. This is why we don't get motion sickness just from wandering around on Earth under the gravitational forces of Earth. So let's go back and let's look at our harmonic situation where we know that acceleration is negative 5 cosine of t. But this implies that the jerk for that pendulum, or excuse me, not pendulum, weight on a spring, well, derivative of cosine is negative sine. So that means that the jerk is 5 times the sine of the elapsed time. And since that graph looks like this, we're going to have our maximum jerk right here and our maximum jerk right here. I mean, minimum, but really it's a maximum just in the other direction. And where on the graph is that? Well, if we think about the fact that we started at the bottom, this is in the middle. And what does the acceleration do in the middle of the spring? Right here, the acceleration changes from the spring pulling upwards because it's stretched to the spring pushing downwards because it is compressed. And so our acceleration is switching directions. We're being dragged in one direction and all of a sudden it's pushing back in the other direction as we switch there. So that's going to be our maximum jerk. All right, for my students, go ahead and do exercise 19 in the book. This was a short video, and we'll be back with the rest of the trig functions in the next video.